For this lesson, we are looking at factoring, and factoring just means to write a polynomial expression as the product or multiplication of two or more other polynomial expressions. So our warm-up here is to fill in the blank space. I've got a blank space, baby, and I'll write a number or a monomial or a binomial. So we're going to fill in this blank space with a monomial or binomial. So the question is here with the first one, what is it that we're going to put in as blank so that when we multiply it by 2x minus 3, we're going to get an answer of 10x minus 15. Well, I know to multiply a 2x, to make it into a 10x, I would have to use a 5. So I'm going to need a 5 here. So 5 times 2x gives us our 10x, and 5 times negative 3 is what gives us our negative 15. So this has a common factor that's a monomial of a 5. Same thing with this next question beside here. I need to change an 8xy into a 16x squared y. So to make an 8 into a 16, I'd need to multiply by a 2. And to make an x into an x squared, I'm going to need to multiply it by an x. And I have a y and I only want one y. I'm not going to need a y with that. I'm going to check that. 8 times 2 is 16, x times x is x squared, and y. Now let's check and make sure it works for the next one. 2x times 3y gives us a 6xy. So that is our monomial here. All right, now I have a minus 5. It has to multiply something to give us a 15x squared minus 25x squared y. So to change a negative 5 into a positive 15, I would need to multiply it by negative and a 3, and I would need an x squared with it to get the x squared that goes here. To have a minus 5 turn into a minus 25, I'm going to need a plus 5, because a negative 5 times a positive 5 is negative 25, but I also need an x squared y with that, so that when I multiply it by that negative 5, I'm going to get what I have as my answer in my bracket there. Likewise, I've got a 5x squared y. I need to change it into a 10x squared y. Well, the variable part's exactly the same here and here. I'm only going to need a 2 to make that into the 10. And then we need a minus 15. So to multiply a 5 by a negative 3, we would get that minus 15. I need an x cubed. I have an x squared. I'm going to need a factor of x to turn that into an x cubed. And I need a y cubed. I only have y to the 1. I'm going to need a y squared to turn that into a y cubed. So if I check by expanding and simplifying, I think my bracket should have a 2 minus 3xy squared. So to factor something means to write it as the product of two or more polynomials. And a common factor is a polynomial that can divide all terms of another polynomial. That might sound really confusing, but we're going to walk through how we can find a common factor. So to get a common factor, it's really this word right here. What does every term in our polynomial have in common with each other? To get the coefficient, so the number in front, for our common factor, you want to find the biggest number that will divide all the coefficients of all the terms in your polynomial with a remainder of 0. In other words, it divides it evenly. And to get the variable part of the common factor, look at each variable separately in the polynomial and pick the smallest exponent of the variable. That variable has to appear in every single term in order for it to be common. So remember, the common factor should divide each of the terms of the polynomial evenly, and you can always check to make sure that you've done it correctly by expanding, working backwards, your factored expression to see if you get back to the original. So factoring really is the opposite of expanding. So make sure you add this key point into your notes, that factoring really is your opposite of expanding. All right, let's try some examples here to see what we can do with this. So, common factor the following. So we want to look for the biggest number that can divide 24 and 16 evenly. So this is where it's good to have strong multiplication facts. There are apps to practice multiplication tables, your multiplication facts. If you're not good at it, I really strongly recommend that you spend a little time looking at that. The biggest number that can divide 24 and 16 is 8. And I have x in the first term, but it's not common to both terms. So 8 is the only thing that would be common. That's our common factor, our greatest common factor. We're going to divide both of our terms in our original polynomial by 8. When we divide 24 by 8, we get 3, and it has an x. When I divide the 16 by 8, we get 2. So if I were to expand and simplify this, I would get 8 times 3x, which is my 24x. My 8 times 2 is my plus 16. So that's a way to check to make sure I've done that correctly. All right, part B, I need the biggest number that can divide 3 and a 9. The biggest number that can divide 3 and 9 evenly would be 3. The variables have nothing in common. One's an x, one's a y. So there's no variable part to this that's common. And then I'm going to take 3x divided by 3, and we get x. Plus 9y divided by 3, we get plus 3y. All right, looking at the next binomial here. 6 and 9 have 3 in common. 3 can divide both, and they both have x. I have an x to the 2 and I have an x to the 1. I always want the lowest, the smallest exponent of the variable. So x to the 1 is the smallest. And now 6x squared divided by 3x would be 2x. A minus 9x divided by 3x would be minus 3. Or think about, what do I need to multiply 3x by to get the 6x squared and the minus 9x? And it's the 2x minus 3 there. All right, next one. I've got an 8, a 6, and a 4. If I look at what's common, the biggest number that can divide all three of those numbers would be a 2. I have an x to the 5, x cubed, and x squared. The smallest power would be the x squared. We have a y to the 1, a y cubed, and a y to the 4. Y to the 1 is my smallest power. And now we divide every term here by the 2x squared y. So 8 divided by 2 is 4. X to the 5 divided by x squared. Use your subtracting exponent rules. You're going to get x cubed. A y divided by y, it disappears. It's just a 1. We're going to have a minus 3x y squared plus a 2. We have an x squared already. I need y cubed because y to the 4 divided by y to the 1 would be y cubed with that. So hopefully that's making sense so far. So factoring by pulling out a monomial, not too hard, but now we're going to change it up a little bit. We're going to look at this thing called factoring by grouping. It really is common factoring still, but in some situations the common factor can be bigger than just a monomial. I know, crazy, right? The common factor can be a binomial or higher degree polynomial. So we're going to look at these following things. Is there anything common with both parts that can be factored? So if I look at my 3x times 2x minus 1 and then a plus 2 times 2x minus 1, you should see that both of these have a 2x minus 1 in common. So what we're going to do is we're going to common factor 2x minus 1 out of the two terms we have there. When I divide the 3x times 2x minus 1 by the 2x minus 1, it gets rid of that 2x minus 1 and leaves you with a 3x. So in this bracket, we would have to times it by 3x. Similarly, when I take this 2 times 2x minus 1 and divide it by 2x minus 1, I'm left with a plus 2. So that is our factored form for that. Now, for people who may struggle with this, think of it this way. If I had 3xa plus 2a, the a here really is my bracket of 2x minus 1. I'm just taking that 2x minus 1 that I have up here and replacing it with a. So I have 3xa plus 2a. The a is the common, and when I divide both of my terms by a, I'm left with 3x and a plus 2. But I don't really have a. What I have instead, I'm going to take that a and put it back in here. Instead of the a, I have 2x minus 1 times the 3x plus 2. So hopefully that makes sense there. In my part F here, I have a 4x plus 1 that's common to both of these parts. So that would equal 4x plus 1 is my common factor. When I divide this whole thing by 4x plus 1, I'm left with the 4x here. And when I divide this part by 4x plus 1, I'm left with a minus 1 here. All right. Sometimes a polynomial may have no common factors that are monomials. However, if you group the terms, like two sets of 2, you can factor something out of each group, which ends up with situations like we have in part E and F above. So we are going to group our terms here. If I look at all of the terms as a unit, I have nothing common to all 4 things. However, if I look at the first pair, I notice 2 is common. And if I look at the second pair, I notice x is common. So here's what we're going to do. We're going to take 2 out of the first pair. That would leave us with an x plus y when we factor the 2 out. And out of the second pair, I'm going to take a plus x, a positive x out. I always have to have a sign with this, a plus x. That would leave me with a plus x plus y, or x plus y in that bracket. Now this is set up like the above examples in part E and F. I have an x plus y that's common to both. We're going to have x plus y common to both, and it leaves me with a 2 and a plus x. 2 plus x as my second bracket. All right, do you want to try the next one? Put it on pause, give it a shot, and then we can talk about it. Okay, if I pair the first 2 together, I'm noticing they both can be divided by a 3 and an x. That would leave me with an x and a plus 2. All right, I want my other one to also have an x plus 2, but right now I'm noticing they're both negative. So what I'm going to take out of those is actually a negative 1, and that will leave me with an x plus 2. Those brackets, to be able to common factor, they have to be identical in every way, signs, letters, etc. So that's going to leave me now with an x plus 2 as my common factor, and in my other bracket I'm going to have the 3x and the minus 1. All right, we're almost done. If you want to try these ones, put the video on pause, give it a shot. I'm going to throw the answers up and then you can check yours. Okay, if I look at the first pair, I've got a 4 and an x in common. Divide the 4x out, I'm left with a y minus 1. In the second pair, they both have 5's and an x squared. I want to have a positive y, so I'm going to make that a minus 5x squared here, which leaves me with a positive y and a minus 1. I have to have these 2 brackets identical in sign and everything, so that helps me decide what sign I'm going to put for that second piece. The y minus 1 is common. We're left with 4x minus 5x squared. Now, I missed something here. If I would have noticed right off the top, if I would have looked more carefully, x is actually common to every single thing. And since I didn't do it right off the top, I'm going to common factor my x out. I'm going to have my y minus 1. I'm going to have an x. And then I would have a 4 minus 5x. Sometimes you'll see that rewritten with the x out in front like this. And the order of the brackets themselves doesn't matter as long as the inside of the bracket has the same order. I could switch the y minus 1 with the 4 minus 5x. It's the same, like 3 times 7 is the same as 7 times 3. All right. Okay, so J is done. K, I want to point out the way it's written. If I pair the first 2 and the second 2 and pull out the common factor, you'll notice that these brackets are not identical. So this was not a good idea. However, if you go into L, it's the same actual terms as K, but written in a different order. And now when you pair them together, we do end up with a common factor. I have an x plus 2 and a 2 plus x, which really is the same thing as x plus 2. 3 plus 5 is the same as 5 plus 3, so we're good with that. So it does end up common factoring
in this way. So if your first don't succeed with your pairings, try again. See if another pair might work.